Assalamualaikum warahmatullahi wabarakatuh. Today I would like to share about addressing modes. Addressing modes help reducing the number of bits in the addressing field of instruction. It also gives programmers facilities such as pointers, counter for loop controls, indexing of data, and program relocation. An assembly language program instruction consists of two parts, which is opcode and operand. An addressing mode focuses on presenting the operand's address in the instruction. In immediate addressing mode, operand of an instruction is an actual value to be operated on. Operand is the address field, which is A. No memory reference is required to fetch the data, so no additional calculation are required to work out the effective address. It is a fast method, but the downside is that it has a limited range. The instruction store considers the immediate value 100H as address, as it does not have hashtag sign in front of it. The store instruction stores the content of R2 at memory location 100H. Next is direct addressing mode. Operand is the memory address that contains the value to be operated on. It requires only one memory reference and no special calculation. Limitation is that it provides only a limited address space. As the example shown, the add instruction includes the memory location A, which has the value to be added to the content of register R2. Direct addressing mode is the simplest of all addressing modes. In indirect addressing, operand is the memory address of a location that contains the effective memory address. Memory cell point to by address field contains the address of pointer to the operand. Advantage is for a word length of n, an address space of 2n is now available. The disadvantage is the instruction execution requires two memory references to fetch the operand. This is the example of indirect addressing mode. Add X will increment the value stored in the accumulator by the value stored at memory location specified by X. In register addressing mode, operand is a processor register if the register contains a value. Address field refers to a register rather than a main memory address. Operand is held in register name in address field. The advantage are only a small address field is needed in the instruction and no time consuming memory reference are required. The disadvantage is that the address space is very limited. Other than that, there are register indirect addressing mode. In register indirect mode, operand is a register containing a memory address. Operand is in memory cell point to by contents of register R. Address space limitation of the address field is overcome by having that field refer to a word length location containing an address. It uses one less memory reference than indirect addressing. The load instruction will load the value present at the memory location contained by register R2 in the register R3. The figure shows how the register R3 get loaded with the value stored in the memory location held by register R2. Next is the displacement addressing mode. The operand is a register containing a memory address. Address fields holds two values. A equals to base value, R equals to register that holds the displacement or vice versa. Most common use are relative addressing, base register addressing, and indexing. For relative addressing mode, the effective memory address is calculated by taking the operand and adding it to the address in the program counter. The program counter contains the base address and the operand is offset to this. It exploits the concept of locality. It also saves address bits in the instruction if most memory references are relatively near to the instruction being executed. The symbolic representation of relative address mode is XPC. the effective address for it will be EA equals to X plus PC. Base register addressing is a version of displacement addressing. It is a generalized relative addressing where other registers can play the role of PC. A holds displacement while R holds pointer to base address. It is EA equals A plus R. R may be explicit or implicit. It exploits the locality of memory reference. Indexing is also a version of displacement addressing. It is very similar to base register addressing. A equal base, R equal displacement. EA equals R, A plus R, but roles are reversed. It is good for accessing arrays. Auto-indexing is the incrementation or decrementation is performed in the same instruction cycle. Stack addressing. Stack addressing is a form of implied addressing. The machine instruction need not include a memory reference, but implicitly operate on the top of the stack. EA equal top of stack. As you can see, these are the example uses of addressing mode. Each addressing mode are different from one another, so it have different uses also.